rocket launch, right? And it's just this incredible display of fire and power. But what you don't see is the battle that's already been won on the ground. A battle against forces so immense, they could literally tear a skyscraper from its foundations. Today, we're pulling back the curtain on the engineering beneath the engines, the part they call Stage Zero.
So let me ask you a question. When you watch that whole spectacle, what part of it do you think is the most critical stage for success?
Well, believe it or not, the answer is the one part that never ever leaves the ground.
That's right. We're talking about the launch pad itself, the unseen foundation that has to deal with forces that are, they're just mind-boggling.
Okay, so first things first. Why do they always build these things next to the ocean? Well, there are two really good reasons. You get a free speed boost from the Earth's rotation if you launch east over the water, and of course, any bits that fall off land safely in the sea, not on a city. But, and this is a huge but, coastal land is basically a swamp. It's soft, it's wet, it's unstable, pretty much the worst place you could possibly choose to build something that weighs millions of pounds.
So how in the world do you build on that? Well, you have to engineer the ground itself. They use a technique called pre-settlement, and the idea is actually pretty simple. You find a way to squeeze all the water out and compress that unstable soil before you start building. That way, the whole thing doesn't just sink into the mud later on.
And engineers have come up with some pretty wild ways to do this. Back when NASA was building the Kennedy Space Center, they just built a massive 80-foot-tall pyramid of sand. The sheer weight of it was enough to squeeze the water out and make the ground sink by 4 feet. Problem solved. SpaceX has a more modern approach. They use something called wick drains. Just think of them as thousands of giant straws shoved deep into the ground, giving all that trapped water an easy way to escape. It takes a process that would naturally take years and gets it done in just a few months.
But even just squeezing the water out isn't going to cut it, not for something this heavy and this violent. The pad has to be anchored deep into the stable earth below, kind of like the roots of a giant ancient tree. So what they do is drive these huge steel and concrete columns, or piles, more than 50 meters straight down into the ground. But here's the really clever part. See how they're angled outwards? That's on purpose. It spreads the insane vibration and thrust from the launch out into the surrounding earth. The source material we used had the perfect analogy for this. It's like bracing your legs before you try to lift something incredibly heavy. It just gives the whole structure stability.
All right, so we've got the foundation sorted. But now comes something even crazier. Trying to tame what is, for all intents and purposes, a man-made volcano. The exhaust from a rocket can hit 3,000 degrees Celsius. Just to put that into perspective for you, that is hotter than the inside of many active volcanoes. So what does that kind of heat do to concrete? Well, your standard stuff, the concrete in sidewalks and buildings, it gives up the ghost at just 300 degrees. See, any tiny bit of water trapped inside instantly flashes to steam and expands, literally causing the concrete to explode from the inside out. That's why launch pads are built with a special recipe called refractory concrete. It's the same kind of stuff they use to line steel furnaces, and it can handle that intense heat and the rapid cool down over and over again. And that, of course, raises a pretty obvious question. What happens if you don't manage all that heat and force properly? Well, the very first orbital test flight of Starship gave us let's just say, a very dramatic answer. So let's break down exactly what went wrong there, step by step. Starship's pad didn't have a flame trench, so that volcanic exhaust blasted directly down onto the concrete. All that hot gas was forced through tiny cracks in the pad until it found the groundwater underneath. Well, that water instantly boiled, creating a ridiculously powerful steam explosion. The result? A steam explosion that launched chunks of concrete hundreds of meters into the air. We're not talking about a few cracks here. The source calls this a geotechnical failure. The ground itself failed. As you can imagine, SpaceX now uses a massive water-cooled steel plate to make sure that never, ever happens again. Okay, so we've conquered shaky ground and volcanic heat. But there's another enemy, an invisible one, that's just as destructive. We're talking about sound. At the moment of ignition, a big rocket can generate sound levels approaching 200 decibels. Now, to be clear, that's not just loud. At that intensity, sound stops being something you hear and starts being a physical force. It's pure acoustic energy, powerful enough to vibrate delicate electronics to death and even damage the structure of the rocket itself. So how do you fight that? How do you protect a multi-billion-dollar machine from its own roar? Well, the solution has been hiding in plain sight this whole time. You know that enormous cloud of what looks like white smoke that erupts at every single launch? Surprise! That isn't smoke.
And its number one job isn't even about cooling the pad. It's all about sound control.
It's called the water deluge system. Just seconds before the engines fire up, it dumps millions of liters of water directly into the path of the exhaust. Now its real job, its primary mission, is to literally soak up that destructive acoustic energy. The water acts like a giant muffler, reducing the killer sound waves by more than 1,000 times. And all that energy it absorbs has to go somewhere, right? It instantly turns the water into a giant cloud of steam. So that massive cloud you see? That's the sound of the launch, made visible.
But even after the rocket is gone, the work isn't over. Stage 0 is locked in a constant, never-ending battle against two more relentless enemies, rust and gravity.
You could say the launch structure is fighting a war on two fronts. On the one hand, you have the absolute need for surgical precision. A rocket that's hundreds of feet tall has to be perfectly aligned down to the millimeter. Engineers use laser surveys to get it just right, and they even factor in a planned lean to account for how the rocket will slightly bend once it's filled with fuel. Then, on the other hand, you have a constant fight against corrosion thanks to the salty air and the incredibly acidic exhaust. The only solution is to use heavy-duty zinc coatings, special paints, and even high-tech metal alloys that were first developed for submarines.
So when you pull back and look at the whole picture, it's pretty clear, right? Stage 0 isn't just the slab of concrete. It has to manage unstable ground, volcanic heat, and sound waves that can kill. It has to fight off rust and gravity every single day. It truly is the first, and you could argue, the most critical stage of every single rocket launch.
And it all comes down to this one simple, powerful idea. We're always amazed by the rocket itself, this incredible feat of aerospace engineering. But as the source material so perfectly puts it, spaceflight begins with civil engineering. So the next time you watch a launch, look past the brilliant fire for just a second and give a little nod to the incredible, invisible engineering holding it all up.
If you're ready to level up, like and share this video. Subscribe and hit the bell to join the future of efficiency. Aera, your life optimized.